Hi, I'm Nguyen. I'm from Vietnam.
And hi, I'm Mi Phu from Vietnam.
Today we will present you about our group project, which is the use of peanut shells for heavy metal absorption in wastewater treatment. And our team it consists of two members, Phung Vu Hành Mi and Chan Việt Phung Nguyen. Here is our table of contents. So first we will go into the introduction. So as you know, heavy metal play a huge role in our society as it has many applications ranging from agriculture to technology. Therefore, however, it is really harmful to the environment. So to remove and collect heavy metals from wastewater, there are many methods that we can use, such as physical method, biological methods, and chemical methods. However, in our opinion, the most popular technique is absorption, which can be easily applied and we can take advantage of the low-cost natural absorbent.
So, what is absorption? Absorption is one of the most widely applied techniques for the removal of micropollutants and organics at low concentration in drinking water production.
So, as a byproduct of peanut cultivation, peanut shells are mostly dumped and burnt up in stacks, leading to a wastage or a huge harmful effect to the environment. Therefore, inspired by the low cost, degradability, renewability, and non-toxicity of peanut shells, it aims to turn peanut shells into absorbent for heavy metal elimination by biosorption process. So let's dive to our experiments.
The experiments will consist of three test stages. The first stage is to collect and pre-treat. The first step is to collect peanut shells, cleanse them with distilled water, and then dry them, and then cut them into small pieces. Let us start with preparing the samples. First, we need some peanut as the agricultural product. And next, we need to collect the peanut cells as the byproduct. Next, we need to cleanse these peanut cells with the distilled water to remove all the impurities in them. I'm going to dry these peanut shells at a temperature of 70 degrees Celsius. After drying the peanut shells for 24 hours, we next gonna cut them into different pieces with a length of 1.5 to 1 centimeters. The width of the peanut shells are keep measured. The second stage is oxidation. The first step is to prepare a solution of sodium hydroxide and hydrate peroxide. And then we soak our pre-treated peanut shells in the solution and wait for the oxidation process to occur. And then we dry the peanut shells. And then we collect two samples of peanut shells with and without oxidation. Second, we need to oxidize the peanut shell with sodium hydroxide and hydroperoxide. Let's start with a loudspeaker, which we're going to fill with 100 milliliters hydroperoxide. Next, we're going to prepare 1 gram of sodium hydroxide. These are the peanut shells that has been dried and cut. I want to collect 20 grams of these. I want to take these peanut shells and stuff them in the solution. The oxidation process is going to take place in the water bath at a temperature of 85 degrees Celsius. After that, I'm going to clean the peanut shells. until the pH is 6.5. Next, I'm going to rise these peanut shells at a temperature of 110 degrees Celsius for 24 hours. The final stage is evaluation. The first step is to prepare a copper solution. Soak the two samples of peanut shells in the solution and then dry the peanut shells and put them for analysis. From this copper chloride dehydrate powder, we're going to prepare a copper solution with a pH 4. We need first to have these two conical flask. We have these two samples of peanut shells, this one without the oxidation and this one with the oxidation. I will collect 1 gram of each into each flask. After adding 1 gram of each material with and without the oxidation in each flask, I'm going to check them at interval of 16 minutes.
I analyzed the copper output by using this atomic absorption spectrometer AA7000 Shimatsu, Japan. So as the light path increased, the amount of light absorbed also increased. So by measuring the amount of light absorbed, I can make the quantitative determination of the amount of analyte.
So after running the machines, we came to two results from SEM and FTIR. So first is the morphology from the SEM result. So the surface morphology of peanut shells before and after modification was shown in figure 1. So the surface image of peanut shells pre-treated by water, which is figure 1A, and on the left, and modified sample, which is on B on the right, was quite similar. However, the oxidation process of cellulose chain happened without the change or the shorten of the length of carbon chain length. So therefore, it can be concluded that the modification process of peanut shells by the hydrogen peroxide converted the hydroxide group to carboxyl group. Therefore, and neither cellulose chain or structure of material was changed. Next is the FTIR result. The figure 2 gives the FTIR result of unmodified V1, and the functional group presented in the modified peanut shell absorbents were expressed in figure 3. Cellulosic hydrogen groups were oxidized to form carboxyl groups as active sites on the structure of peanut shells. The mechanism could be further confirmed by the FTIR spectra of modified sample V2, and the peaks observed at 1070 and 47.191 centimeters could be assigned to the carbonyl group of COO formed due to the modification of peanut shells. This peak didn't occur on the spectrum of sample B1, which was only preceded by water. So therefore, it can be concluded that hydrogen peroxide modified peanut shell presents a chemical characteristics to absorb metal ions. So therefore, we conclude our absorption experiment. So the figure 4 presents the heavy metal removal efficiency of peanut shell pre-treated by water and modified peanut shell. So the absorption efficiency of peanut shell dramatically went up after being treated. So from nearly 70% to 95%, the absorption capacity results at this pH 4 for unmodified and modified material were 1.74 and 2.39 respectively. So the rise of 30% of absorption capacity proved that the modification process by oxidizing the hydrogen oxidant with hydrogen peroxide in an alkaline medium was effective. So next is the challenge presented by me.
In order to run this project, we have to face many stages of challenge. The first step is to finding the topic for the research because there are lots of environmental issues to look into, choosing one from a big pool of problems is not an easy task. Our team has brought forward many ideas, but in the end, we decided to focus on water pollution. We were inspired by a polluted river in the capital city, Hanoi. The next issue is to figure out the progress in how to write a proper scientific paper because it's our first time doing so. And the last issue is time management because we all have different schedules, so it's hard to hold a meeting. And our solution to the problem is to read a lot of newspaper and scientific papers to learn from them. And we also have a very supportive mentors who guide us through the whole process. And last, we make a timeline for everyone to follow. And luckily, we successfully complete our research.
So next is our application for future use. So we want to use the peanut shell first to treat a small amount of water, such as in the household, in case we need it. For example, an accident circumstance that we cannot use our filter machine, so we can use peanut shells as a good absorbent for my scenario. So our improvement will have to meet all four criteria in the slide, as enhancing the productivity, is environmentally friendly, it is sustainable to the development, and it must be affordable and cheap so everybody can use it. So that's our goal in the future.
So thank you for listening to our presentation.